Guys, Sandy here. If you haven't seen the videos already, watch my previous videos on these DC LED lights that run off between 10 and 36 volts. One on tearing these light bulbs down entirely, another one on testing them. This is the device, the new version. The other one got torn apart and cannibalized. So, you can see I've got my dimmer. Dimming capabilities, yes, it gets very bright. I fixed the dead zone on the far side. So in my previous video I had a very large dead zone on both sides. This is what the dead zone looked like before. So all of this was dead zone, all of this, and then only this fraction of the entire turn radius of the potentiometer was actually usable. So I solved that using a 2000 ohm resistor, and I have a bypass. So see, middle switch kills power, so there's no power going to any circuitry at all. Now there is, it's going through this guy. Let's do a quick test. This light gets pretty damn bright. So right now it's reading 1 amp of draw on the dimmer switch and 28.8 watts. 28.5 watts if it's direct. Okay, that's interesting. So let's dim this down. That's so bright. So this circuitry inside of here wastes 0.3 watts. See, this is the nice part. See, I'll start dimming it down. Yeah. Let's see if it actually does go to 29. There we go. There's an inefficiency spike right there. There's no visible change. See, there we go. We're about halfway. It's just when it starts to dimming, it'll spike it up. It's interesting. See, you can bring it right down to where it's not even visible. This is why it's nice to have dimmer switches. If you're going to be running off batteries and you're going to be running these, the only point is so that you can save power. And what better way to save power than if you can dim it to the point where it sips power, right? Let's look at this horrible contraption. I did a pretty good job of making all the wires really tight in together. Alright, so I felt like the diodes were the diodes are good, but it's not gonna, you know, it's wasting power, right? So anyways, there's just that potentiometer. The 2K resistor is right down there. The amperage one you don't touch. It's nice to use these wall plugs, makes it so much easier to do things. I put everything on plugs. Another thing, I'm going to be redesigning, I think one final integration. I want a breaker on this side and on this side for safety's sake. And I'm going to rearrange a lot of things. I'm going to have it so that there isn't this light switch. I'm going to have two set. I got this idea from, it was from the guy who makes the BMSs and all that stuff. He lives in Saskatchewan. I was watching his videos. Anyways, so the BMS is going to be always connected, but it's going to go to like lights, because the lights will just run and run until they flatten the batteries and wreck them. So the BMS will turn off the whole circuit if the batteries get too low. So that's why I want to run it through. And then the inverter would run directly from the breaker. But the BMS negative has to always be connected, and that was a big error with this design. I've been running all of these, so these 3 lights and these lights, not this one, but these 2 here. I put them on a switch. I have them running off this wire. No issues. I've been running them forever. Yeah, this is another reason why I wanted to use plugs. This is all going to be torn apart again, because this isn't a real BMS. These 50 amp BMSs are not real BMSs. They don't actually balance. All these lights have been running fully, so that much wattage, you know. So 44 watts is being consumed by 5 LED light bulbs right now. Pretty good, 1.7 amps, 25.5 volts. So I want to keep running it. and I want to see if the BMS will turn it off. Pretty ugly. I did a really messy epoxy job and then created my own back plate. If you want to see something look nice and pretty, then you're probably in the wrong place. I'm going to build another one, that's why I bought so many of these. I'm waiting on the potentiometers, but I couldn't wait. It looks much nicer. You have to agree, this looks very nice. These things just came in the mail. This YouTube video is probably going to be a real mess, but it doesn't matter. Kind of sucks that, you know, parts came in right after I finish a product, because I'm not going to redo that one just to put this switch in. I have like 3 of these that I bought, so I'm not going to rebuild that other one. I'm just going to build this one instead, since I have enough parts to build 3 of these dimmer switches. If you reverse polarity this, it melts this potentiometer, and that's it, which is nice. So this is 2K, this is actually 2.2K resistor. These 2 middle terminals are power in. This one here will go to the light bulb and to the output of this. So these 2 will wire into these 2, which will then go up to the light bulb. And then these 2 will go to the input of this. I like having the click on off, I really do. But these are 5K pots. I need 2K pots. I don't like this because it's a lot better to have this wall plug. It makes things so much easier. So, but anyways, this is this one done up. So the way I cut this out is I used a Dremel. These rockers are much nicer, very professional looking compared to this guy. I didn't like these at all, but whatever, you know, live and learn, right? I found these fuses, these glass fuses, so I think I'm going to use them. This is as low as it dims, which I think is reasonable, and that way you know that you have to turn it off. There. So, turns up, and it gets super bright. This is a 1K potentiometer in here, and it doesn't have the on-off switch. So, there's the potentiometer, because you have to drill 2 holes for the potentiometer, if they'll ever focus. So, you can see it on this other side, you have to drill 1 small one and then your main hole. And I crammed it up. I used hot glue to solve an issue with there being a little bit too much of a gap in this one. In this one I did it perfectly. This is my first go, no issues. I cut it out perfectly. And then this one I messed up because this was actually, so it had that light switch. It was that rectangular piece, so I had to work around cutting around it, and I made a tiny mistake with that. So I used hot glue just to secure it better. I soldered some of it, and then I used these quick connects for the output wire. Felt that was good. I had to crimp them a little bit though because they were just too loose. And then I used a lot of hot glue. I put a lot of hot glue between there and the plastic, the white plastic. I put it in a lot of places. It just does a really good job of holding everything together. But yeah, it's very tight, very compact. I didn't need the zip ties, but I felt safer putting the zip ties in. And I'm just running it through there. I'm going to wrap the wire in electrical tape. I put this knot here so you can't pull the wire out. It was just easier to do this type of knot, and that'll protect it. Right? Very simple. Because it was like $5-6 for this metal piece, and to have the 2 gang of this was very ugly, and it was all fully insulated. They didn't have non-insulated plastic ones, which I was very disappointed with, but c'est la vie. A lot more work to do, but I'm glad that I completed this. I feel like I have a final product. I've done a lot of testing, and it's run great. 8 light bulbs, 73.5 watts, almost 3 amps. I'm very happy with that. Switch it over to dimming capabilities. It still really does a great job of linear dimming. So an example is like, see, that one's off, that one's off. None of the other lights are getting brighter, so it's got proper CCCV control. Because otherwise, if the buck converter in here was crappy, as I turn these off, the other ones would get brighter because that amperage would then be diverted to them. But it's flawless, like you don't even notice it. So very good circuitry. So there it is in its final stage. To make it look a little bit nicer, this hole here, you could fill it with white silicone, and I doubt they'd notice. Preferably I'd put the same type of white painted screw heads here as well, just for aesthetics. Mounting it, we've got holes on either side, so even though it's fully put together, you can still stick it in. Now note everything's contained on the faceplate, and these are unbreakable nylon wall plates. Very strong, very highly recommended. They're cheaper than the ones that are brittle and shatter. So I've put some electrical tape around it to protect it since sharp edges thing, but you could also put silicone around that as well. Prevent any kind of vibration and movement that would eventually breach it. As far as I'm concerned, this is a final prototype. Anyone's built after this, I doubt they're going to change much. I got rid of the diodes in it. I just I noticed that there were heat buildup losses. Nothing worrisome. This is the old design from the battery. Double pull, double throw switch here. Got rid of that diode. I got rid of this on-off switch here, didn't need it. Instead of 5K, it's a 1K or a 2K potentiometer and 2K resistor. This diode is removed. I'll do testing and figure out if these diodes cause any issue. These two diodes here. I don't know if they burn up more energy to a point where it's a concern. I put the fuse on the end here with the diode. I wanted the diode and the fuse to be external. Since this is more portable unit, I felt it to be best. I changed this, cleaned it up a lot. Okay. So, yeah, that's what it looks like. Much cleaner. It's got a 3 amp fuse in it, so it's perfect. And yeah, it's only consuming 1.8 amps, so very happy with that. But yeah, I use this fuse holder and this fuse. I felt like this would be much better. And I've got a master on off, and in the future I can probably tie in more objects over here, so I have a master kill and I can leave this alone. But in the future I'd like to have a bus bar. 24 volts, the BMS turning off all these lights up here, so that's pretty cool. That equals out to 3.4 volts. So when the batteries are at 3.4 volts, turns off the lights. Pretty happy about that. I kind of wish that I would bring it down to 22. What's 22? So yeah, 22 is 3.14 volts. I don't know if that's too low, but 24 is good. Lasted forever, right? 3,600 watt hours. There's probably more than that because it was at 29, not 29.4 when I started. It took quite a long time to figure out how I wanted to implement all of this. And there's a lot of different things that I want to work on in different ways. So it's really difficult for me to prioritize and decide what takes precedence. I know I sat in my chair just staring at a lot of this equipment. I cleaned it up now, but like all this wiring, all this electrical wiring down here and here, it was all over the floor. I should have taken pictures of it. The place, you couldn't even walk in it. But I'm pretty happy. I'm unfortunately very split on which projects in the future I'm going to do next and what priority list. But I have a lot of different things I'm excited to move forward on and continue with. This is definitely high priority. It's been sitting forever. I need to get these done. I have to order more of these. I cooked too many of them. I fried them. I blew up one of these too by accident, so that was unfortunate. But anyways, yeah, I hope you liked the video. I hope you found it very fascinating. I know it was a little all over the place, but that's okay. There's so much stuff. I even went through all of my transistors and relabeled them. I completely organized, well, kind of organized it. It was a big mess. It's crazy. I got so many different things I want to do, and I still haven't gotten to testing these out properly again. No big deal though. So I hope you liked the video. I'm going to be posting an update video. Stay tuned for that, and I'll describe my plans for the future and what I've been working on, because it's been a little while since I made my last video, but I certainly haven't been sitting idle. Like, comment, subscribe for more, and I hope you really enjoy it, and I hope you have a wonderful 2019, guys. Thanks. Bye.